Good morning, students. Welcome to the physics class. Today we are going to continue with the chapter Work and Energy. In the previous topic, we have discussed about potential energy and kinetic energy, isn't it? Now today we are going to continue with that and we are going to discuss about number 1, conservation of energy, its law, then concept of power, and finally we will discuss commercial units of energy. Before starting, let's look upon the learning outcomes of the day. Students, after the completion of the topic, you will be able to number 1, state the law of conservation of energy. Then describe the conversion from one form of energy to another, how the energy get converted from one form to another, like lighting a lamp. You would see electric energy gets converted into light energy. Similarly, you will be able to describe various conversions. Okay? And lastly, you will be able to apply the concept of work, energy and power to solve the various numerical problems. Okay? Please note these outcomes so that after the end of the topic, you check yourself whether you have achieved these outcomes or not. So students, let's have the quick revision of the topics that we have discussed previously. First is kinetic energy. As we all know, it depends upon mass and velocity. Now students, can you write know the formula? What is the formula for kinetic energy? Yes students? Yes, it is half mv square. Okay? And it depends upon, yes, it depends upon mass and velocity because its formula is half mv square. Okay? So everyone knows the formula for kinetic energy is half mv square. It depends upon the mass and velocity. Means if either mass or velocity will increase, then kinetic energy will also increase. Okay? Now next, kinetic energy, the units that we use is joule, and we can write joule as kg meter per second square. How? Because unit of mass is kg and unit of velocity is meter per second, and on squaring, because here it is v square, you get 1 joule, that is kinetic energy, can be written as 1 joule can be written as 1 kg meter square per second square. Okay? So SI unit is joule and it is same as that of work done. Now let us solve the examples related to kinetic energy. So first of all, you must know that kinetic energy is half mv square. Only then you will be able to solve. Now here it is given that kinetic energy we have to calculate for a van of mass 1000 kg moving with velocity 2 meter per second square. So mass is 1000 kg and velocity is 2 meter per second. So you can apply the formula and see half m is 1000 and v is 2. After solving you will get 2000 joules. So dear students, note here 1000 means kilo. So 1000 joule can be written as, if it is 2000 joules, we can write it as 1000 means kilo, so we can write it as 2 kilo joules. Okay, clear? Now similarly, second case, here again the van is there but it is loaded, so its mass has increased to 2000 kg. Velocity remains the same. Again applying this half mv square, you will get 4000 joules or 4 kilo joules. Now finally, calculate the kinetic energy of the unloaded. Unloaded means here mass you have to take, yes, 1000, because empty van's mass is 1000 kg. So unloaded van means 1000 kg mass when its speeds is 4 meter per second. So you will write here 1000 for M and V के लिए you will write 4 and you will get 8000 joules. Now what can we write to 1000? Yes, kilo. So 8000 joule can be written as 8 kilojoule. So finally, just see the final slide for kinetic energy and then we will able to solve some typical numericals also. Kinetic energy's formula is half mv square, and you can get from here that if mass of the object is increased, doubles, then kinetic energy will also get doubles. And if velocity get doubles, then what happens? Velocity is not here the linear, it has the power 2. So if velocity will increase, velocity will get double, then kinetic energy will be 2 square. That is, it will increase by 4 times. Okay. So let us solve this typical one of the typical numerical. Here motorcycle accelerates at here. This is the, what is this? 2 meter per second square? Yes. From the this units you can see meter per second square. Also here it is written accelerates. So it is acceleration. Acceleration is 2 meter per second square. From rest से start हुआ है motorcycle. From rest means you are to take u equal to 0 and it is accelerating for 5 seconds. So time will be 5 seconds. Find means you have to calculate kinetic energy after 5 seconds and mass is given to be 200 kg. So whatever is given you have to write first. Okay? You will write here acceleration is this, u is this, t is 5 seconds. For by applying first equation of motion v equals to u plus at, you will get a is equal to v minus u by t. Okay, here you can apply the formula to calculate the v. V can be calculated here as 10 meter per second. Okay, then we have to calculate the kinetic energy. For kinetic energy we need mass and velocity. Velocity we have calculated, mass is given. So applying the formula half mv square, you will get half into 200 into 10 square and that is 10,000 joule. Again 1000, we can replace this 1000 by k, that is kilojoule. So students, work kinetic energy theorem. What does this mean? Actually, this is a change in kinetic energy equals to work done. What does this mean? Means whenever whole of the work get converted in increasing the speed of a body. Means when we are applying the work and the force on the object, work done by the force on the object, then you can see only the change is in the speed of the object. If the only speed of the object is changing, that means work done will be equal to the change in kinetic energy. Okay, so this is work energy theorem. Also work kinetic energy theorem भी कह सकते हैं, work energy theorem भी. So it is work done is equal to final kinetic energy minus initial kinetic energy, that is half m. V square is final velocity, so final kinetic energy will be half mv square minus initial, so we can write it as half m u square. So I have taken half m common, so we can write work energy theorem as this also. So when speed will increase means if the speed of the object is increasing, then that means v is greater. So work done will be positive. But if speed is decreasing, that means its u is more. पहले ज़्यादा होगी, बाद में decrease हो रही है. That means this expression will be the negative. That is work done will be negative. Okay. So let's come to the next energy, that is potential energy. We have discussed in detail about the gravitational potential energy. Yes. So what was the formula for that? It was m into g into h. So here gravitational potential energy is calculated by multiplying mass, acceleration due to gravity and the height above the ground level. Again SI units are joule and we can write it as kg meter per second square for g and h for meter. Again you will get kg meter square and second raised to power minus 2. Per second means raised to power minus 2. So SI units are joule as such and we can write it as kg meter square per second square. ठीक है जी. And see the conceptual questions related to gravitational potential energy. Means first is, if you are lifting a bag, you are lifting means you are increasing the height of the bag from the ground. What can you say about its gravitational potential energy? Yes, as you are increasing the height, and the formula is mgh, h is being increased, so gravitational potential energy will also increase. Same again here, lift the same bag on moon. If you are not on earth, you are on moon. Is there any g on moon? Yes, there is g on moon, which is 1/6 the g on earth. ये हमने लास्ट चैप्टर में किया हुआ है. तो g तो वहां पे है, इसका मतलब m तो ऑब्जेक्ट का मास है, एंड वी आर रेजिंग, हाइट भी है. तो what happens to its potential energy? Again it will increase. But third question is, will the gravitational potential energy be same for earth and for moon? Yes, on earth and on moon, will that be same? The answer is no, highly no, because acceleration due to gravity is not same, है ना. तो उस हिसाब से अर्थ और मून पे gravitational potential energy will also be not same. So as g is lesser on the moon, it is 1/6 that of earth, so gravitational potential energy will be less on moon. Okay ji. So let's solve the numerical. Here it is given that you have to lift the books of mass 3 kg for 2 meter, and what will be its gravitational potential energy. So dear students, acceleration due to gravity is 9.8, no doubt, meter per second square, but you can take it as 10 also. Now what is the formula for gravitational potential energy? Please speak along with me. It is mgh. Here mass is 3, okay, and g is 10 and height is 2, so you can here multiply these 3 and you will get the answer 60 joule. Find the work done by you to lift the books. Now you have to calculate what will be the work done. Here you can see whole of the work that is being done on the object is used up increasing its height. Only height is increased. So that work done will be stored as the potential energy. So work done will be same as that of potential energy. So we can calculate here as force into the displacement covered. Here force is the weight of the books, and weight of the books means mass is 3 kg. What will be weight? mg. So 3 into 10, that is the weight of books. Multiply the displacement, and the displacement of the books is by 2 meters. So again you will get 60 joule. Okay ji. Now here the next topic of the day, that is conservation of energy. To understand this concept, let us see this hourglass. What is this? Here energy of the object can be thought of as sand in the hourglass. How? Sand is inside the hourglass. No doubt it is moving from one part to another, but total amount of the sand inside the sand glass remains same all the time. Similarly, energy always remains the same or remains fixed in quantity. You can see here sand can change the position from top to bottom or bottom to top when we invert it. Okay? Then, but there is the total quantity of the sand remains the same. Similarly, energy, total energy remains the same. It can only change from one form to another, either from kinetic energy to potential energy or vice versa, from potential energy to kinetic energy. Okay? Let us explain it further. So please note here that energy cannot be created nor be destroyed. हम कभी भी energy को create नहीं कर सकते. We cannot even destroy it. So what does this mean when we are seeing toward viewing it in context of the earth? That means total energy of the earth is the same. It was same. It is same, and it will remain same. Then how can we see the advancements, energies? We can say we are generating electrical energy, we are generating nuclear energy. What does that mean? That means we are not actually creating, we are transforming. Let's explain it. We are just converging. What does the conversion means? Conversion means we are just changing the energy from one form to another. For example, Simple example, burning candle. In burning candle, chemical energy gets changes into the chemical energy that is stored in the wax, it gets converted into heat and light. Similarly, when fuel is burned, chemical energy of the fuel gets converted into heat, and then it can generate kinetic energy as well as electricity. Thermal power plant में electricity भी generate हो जाती है. Then nuclear explosions में what happens? Nuclear energy gets converted into heat and then light also. Similarly, if we have a spring, that elastic potential energy gets converted into kinetic energy. So, what is law of conservation of energy then? That means, सारा हम conclude करेंगे अब. It means energy can neither be created nor be destroyed, but can be transferred from one form to another. In such a way, total energy before and after transformation remains the same. So we have the 3 points discussed here, the 3 points. So let's see what are that. And please note here, the total energy is always the sum of kinetic energy and potential energy. To understand this, let us see one example. Freely falling object model. Here what we are seeing is, here this ball, it is freely falling and moving towards the ground. What happens to it is, there are various energy conversions, that is kinetic energy, potential energy. When the ball is at the highest point, here just we are going to drop it, okay? When the ball is at the highest position, its height is maximum, so it is having the highest value of its potential energy. So gravitational potential energy will be maximum. Since we are just to drop here, no velocity is there, so kinetic energy will be 0. क्योंकि kinetic energy में there is half mv square, तो velocity यहाँ नहीं है, so kinetic energy will be 0. But when this object is falling, we have dropped it, it's falling. Let's see here it is in the midway. What happens here? Here its h, that is height, it has decreased, h is decreased, okay? It is only now this much. And what happens to its velocity? Its velocity has increased. Means height decrease, that means potential energy has decreased. So potential energy keep on decreasing when it is falling down, and its velocity keep on increasing because of the acceleration due to gravity. Its change in velocity will be there and it is increasing, so kinetic energy will increase. Now at the lowest position, just touching the ground, abhi touch nahi hua, just before touching that, what happens? The kinetic energy will be maximum, and as such the height is minimum, so potential energy will be almost 0. But the sum total of energy, जो अभी हमने पीछे देखा था अभी, that is the sum total of energy will remain the same, and it will always be the sum of kinetic energy and potential energy. Okay? So let us summarize. The principle of conservation of energy states that number 1, energy cannot be created or destroyed. Number 2, energy can change from one form to another. And number 3, the total energy remains same. It is always constant. Okay, dear? So the next topic is power. As the name says, power means how fast we are doing the given work. What is our power? Means what is the our rate of doing the work. Okay. So power is nothing but the rate of doing work or the rate of the transfer of energy, that is called power. It is denoted by symbol P, and the formula is work done upon time. Okay. Power is work upon time. Work is what? Energy. What is the? Because capacity to do work is energy. So we can also write it here as energy by time. And what are the SI units? Power's SI unit is watt, and here you can see it is energy by time. So 1 watt, that is, this is watt. 1 watt can be written as energy by time, that is 1 joule upon second. So joule per second can be written as watt, or you can say joule can be written as watt second. Okay जी, ये दिमाग में रखना because आगे हमारे we are going to use this concept. So power, as a unit of power is watt, as a unit of energy is joule, as a unit of time is second. So how is watt related to joule? 1 watt is equal to 1 joule per second. Okay dear. Now next concept is average power. Average power means total energy consumed upon the total time taken. We will just see how much total energy has been consumed and what will is the total time taken and divide them. Okay. So let us summarize here also. The SI unit of power is, yes, watt, and the formula for power is, yes, energy by time or work by time, and we can write it as the SI unit can be written as joule per second also. So again here another formula for power, as power can be written as work upon time and work can further be written as force into displacement. So power can be written as force into displacement upon time, isn't it? Now here students, please note here displacement upon time. This displacement upon time can be written as, yes, it can be written as velocity. So the new formula for power is power is equal to force into velocity. So you can also use this in solving the numerical problems. Okay dear. And but commercially, as in day-to-day life, the units of power that we are using is not watt, it is horsepower. Okay, horsepower is we can write it as HP, and it is related to the SI units watt, as 1 horsepower is equal to 746 watt. Please note here the value 746 watt. Okay, 1 horsepower. So let's solve the numerical. Here a little Nelly Newton lift her 40 kg body a distance of 0.25 meter. Okay, she is lifting her body of 40 kg. Here mass is given and the distance, that is upliftment, usne kitni ki, that is given in 2 seconds. Time is also given. Okay dear. Now what will be the power? Power means energy by time, work done by time. So पहले we will calculate the work done. So work done के लिए we will use the force and the displacement. Here force is its her weight, that is mg into s. So mass is 40 and is moving against the gravity. So g is 9.8, rather it should be minus 9.8 because moving against the gravity, and the lifting up is this is 0.25, so we can write here as the distance is 0.25 meter. After solving you will get 98.1 joule. Okay dear. Now this work done is there and the time is given to be 2 seconds and we are to calculate power. Don't forget, we have to calculate the power. So power is work done upon time. Work done is 98.1, or here students, if it is taken as 10, then the work done will be 100 also. Okay, so approximately it is 100 joule. So power is will be work done upon time. So 100 upon 2 ले लो या 98.1 upon 2 ले लो. The answer will be 49.05 or it is 50 watt. Okay dear. So the last topic of the day is commercial units of energy. But commercially we are not using the units of energy as joule. As commercially for power we are not using watt, we are using horsepower. For energy we are using the units kilowatt hour. Let's see how. As you know, power is energy by time. So what will be energy? What will be the formula for energy? Yes, it is energy is power multiply time. To understand this, let us see. We have a machine that uses 1000 joule of energy in every second. It is using 1000 joule, means 1 kilojoule energy per second. If this machine is used continuously for 1 hour, time is 1 hour and energy is 1000, okay, then what happens is it will consume 1 kilowatt hour of the energy. It is using per second 1000 means power is 1 kilowatt, and it is used for 1 hour, that means time is 1 hour. So total energy will be 1 kilowatt hour. ठीक है, that is 1 kilowatt hour is the energy that is used in 1 hour at a rate of 1000 joules per second. अभी समझ नहीं आएगा, let us explore it further, then you will get it. ठीक है, थोड़ा सा it's a typical, otherwise it will be it is very easy. For example, electrical energy used during a month is expressed in terms of units. Okay, जो घर में हमारे electricity bill आता है बेटा, that is using the units. We are not saying kilowatt hour, we are saying its units कि 400 units थे इस बार की हमारी consumption of electricity, है ना. So that unit is what it is actually. 1 unit means 1 kilowatt hour. ठीक है, layman just say unit, otherwise in scientific it means 1 unit means 1 kilowatt hour. Okay dear. So commercial unit of energy is kilowatt hour, जो हमने regular use करते हैं commercially, and SI unit of energy is joule. Is there any relation between these two? Let us see. Yes, there is relation, and it is very important for the exam point of view. There is always mostly the question comes in 3 marks. What is the SI unit of energy and what are the commercial units of energy? Also write the relation between them. ठीक है, let us see what is the relation between the commercial units of energy, that is what, yes, kilowatt hour. ठीक है, 1000 watt की कोई भी instrument, कोई भी device, if it is working for 1 hour, then its energy will be 1 kilowatt hour. ठीक है जी, energy consumed will be 1 kilowatt hour, and SI unit of energy is joule. ठीक है, let's see the relation between them. Here students, 1 kilowatt hour we can split it as 1 kilowatt into 1 hour. ठीक है, now 1 kilowatt means, yes, it means 10 raised to power 3 watt या 1000 watts. ठीक है, and 1 hour if we convert it into the SI, what you will get? It will be 1 hour can be written as, yes, 3600 second. कैसे? Multiplying 60 by 60. If you will multiply 60 with 60, that is 1 hour is equal to 60 minutes. Multiply 60, that means it will be 3600 seconds. So we are using 1 kilowatt hour as like this, and if we put these values, what you get is 1 kilowatt hour is equal to this, as I have explained you. So 1 kilowatt can be written as 1000 watt, and 1 hour can be written as 3600 seconds. So you will get 36, then followed by 5 zeros. Okay, 36 lakh joule हो गए. Now students, do you remember? You can write here like this. It will be written as 3.6, and then with a number of zeros are 5 and 1 decimal we have taken, we have included the 6 also. So the number of terms after the decimal is 1, 2, 3, 4, 5, 6 terms. So we can write it as 10 raised to power 6 joule. Scientific notation के लिए we have to write this. Scientific notation says that whenever you are to write the number, you must write the decimal so that one number before the decimal is non-zero number, and after that you can write the multiples with 10. ठीक है, 10 की पावर के साथ हम लिखते हैं scientific notation. Otherwise this is also okay, you can write 36 lakh joule also, but for scientific notation you should write 3.6 into 10 raised to power 6 joule. So this is the relation, 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 joule. So please remember this equation. So students, here is the activity for you. It's also given in your NCERT book. Just you have to take a close look of the electric meter of your house. ठीक है, it is like there's a reading written like the odometer of your vehicle also. ठीक है, these readings are actually telling us about the units of energy that we are consuming. Okay, it is the units are written here kilowatt hour. So kilowatt hour में अगर एक division आगे move करता है ये, that means we have used 1 unit of the energy. ठीक है, so every day at 6 a.m. and 6:30 p.m. 2 times a day you will note the reading of your meter. What are the readings? Okay, make a table of this. ठीक है, and do this activity for 1 week, and after that you have to calculate the number of units that your house, your home is consuming. ठीक है, and calculating and what is the difference, either it is same during night and during daytime. Just tabulate your observations and then we will discuss next week. Okay dear? ठीक है जी, and by using this you can also calculate the how much electricity is being consumed by your various instruments also. So we'll discuss this next week. To start doing this activity. Okay, that's all for today. Thank you students.